Number 5. The Phoenix Cluster. Located at its namesake constellation, the southern constellation of Phoenix, this massive galaxy was named after the phoenix, the mythical bird that rises from its own ashes. Within this cluster we find HLX-1, roughly 20,000 times the mass of the Sun. HLX-1 is the catalog designation of the black hole's host galaxy, a spiral galaxy similar to the Milky Way in the southern constellation Phoenix. HLX-1 stands for Hyperluminous X-ray Source Number 1, which means it is the first X-ray source of its type discovered in the galaxy. HLX-1 brightens and fades over a period of roughly 367 days. Its X-ray brightness increases dramatically in about 10 days, falls slowly over the next 100 to 200 days, then stays low until the next flare-up. A possible explanation is that the accretion disk is fed by a star in an elongated orbit. When the star comes closest, the black hole's gravity pulls gas from its surface. The gas funnels into the accretion disk, heating the disk and causing it to emit a burst of X-rays. Over the next few months, the black hole ingests some of the gas, so the disk fades. The Phoenix cluster is 5.7 billion light-years away. Number 4. NGC 4889. In the constellation Coma Berenices, lies NGC 4889. NGC 4889's black hole may be a dead quasar, an object that once shined more brightly than all of the stars in the galaxy combined. When the black hole was born, it was surrounded by vast clouds of gas and dust and millions of stars. Much of this matter was funneled toward the black hole, forming a broad, thin, superhot disk. Strong winds of particles from the disk, as well as the pressure of the radiation itself, soon blew away most of the remaining matter close to the black hole. When the last of the matter in the accretion disk was either ingested by the black hole or blown back out into space, the quasar shut down. Today, the black hole is quiet. An occasional star or gas cloud strays too close to the black hole and is gobbled up in a blaze of energy. However, adding a tiny bit to the black hole's record-breaking mass, the mass of this object is around 9.8 billion to 27 billion times the mass of the Sun, and a diameter roughly 6 to 17 times the size of the orbit of Neptune. NGC 4889 is 335 million light-years away. Number 3. APM 08279 plus 5255. Located in the core of the constellation Lynx, we have a broad absorption line quasar called APM 08279 plus 5255. APM 08279 plus 5255 was initially identified as a quasar in 1998 during an automatic plate measuring facility, APM, survey to find carbon stars in the galactic halo. The combination of its high redshift and brightness made it the most luminous object yet seen in the universe. Its discovery shows that water has been prevalent in the known universe for nearly its entire existence. The water vapor is spread out across 100 or more light-years of space surrounding the black hole, making the actual density of the gas some 300 trillion times thinner even than Earth's atmosphere. Radiation was emitted 1.6 billion years after the Big Bang. APM 08279 plus 5255 is a giant elliptical galaxy with large amounts of gas and dust and an active galactic nucleus, AGN, at its core. The AGN is powered by a supermassive black hole of 23 billion solar masses. The black hole is surrounded by an accretion disk of material spiraling into it, a few parsecs in size. Further out is a dust torus, a donut-shaped cloud of dust and gas with a radius of about 100 parsecs. Both the accretion disk and dust torus appear to be almost face-on to us. APM 08279 plus 5255 is 12 billion light-years away. Number 2. H1821 plus 643. H1821 plus 643 is a quasar situated within the constellation of Draco, with a diameter 28 times the diameter of Pluto's orbit. It is situated in a massive, strong cooling flow cluster. Astronomers in 2014 identified H1821 plus 643 as the most massive black hole with a precisely measured mass, at 30 billion solar masses. H1821 plus 643 is significantly different to that found in other galaxy clusters. The entropy and temperature are significantly lower, and have much steeper gradients, than is observed in other massive cool core clusters. The entropy prole within 80 kpc from the core lies significantly below the baseline entropy prole for hierarchical structure formation, a phenomenon which has never been observed before. H1821 plus 643 is 3.4 GeV away. Number 1. S50014 plus 81. S50014 plus 81 is a distant, compact, hyperluminous, broad absorption line quasar or blazar located near the high declination region of the constellation Cepheus, near the north equatorial pole. The central black hole of S50014 plus 81 is actually 10,000 times more massive than the black hole at the center of our galaxy, or equivalent to 40 billion solar masses. S50014 plus 81 is also 47 times the distance from the Sun to Pluto. The host galaxy S50014 plus 81 is an FSQR blazar, a giant elliptical galaxy that hosts a supermassive black hole in its center, which may be responsible for the intense activity of this blazar. What is even more astounding is that the monstrous black hole exists so early in the universe, at only 1.6 billion years after the Big Bang. This suggests that supermassive black holes grow up very quickly. However, there are some cautions about the study. First, the method used was actually an indirect method of calculation, and not Keplerian orbital estimation, the latter being a more precise estimate. It is unlikely for a quasar as luminous as S50014 plus 81, which will just outshine the stars within its vicinity, thereby making estimates very inaccurate. Second, the spectra used is actually a long spectra, not accounting for the observed parameters. Third, the quasar is surrounded by a large accretion disk, a few parsecs in size, and it shines at 40% of its Eddington luminosity, the maximum luminosity through which radiation pressure is strong enough to blow up the disk away from the gravitational influence of the central black hole, so the observed characteristics are unknown due to intervening dust and gases. However, the possibility of an ultramassive black hole has not been ruled out entirely, since only a black hole of that mass can account for the observed power output of the quasar. S50014 plus 81 is 3.7 GPC away.